Hey guys, so today we're going to be doing some more practice with implicit differentiation. And what I'll be doing to go through this is I'm going to be going over the implicit quiz that I took last year. And I think he gave it to you guys. I think Mr. Martin gave it to you guys as like a extra extra practice worksheet. So I'll be going over that. And sorry in the beginning because I'm a little bit sick, so I know my voice is like all nasty. But anyways, we'll just go right into it. So for the first one, it was calculate dy over dx given x squared minus 5y squared equals 4 plus x squared minus 5y squared equals 4 plus 2xy. Right, so the first thing is we take the derivative of this, right? This whole thing. This one's pretty easy, we just do it term by term. So the derivative of x squared, that's going to be 2x by the power rule. And then we have minus 5, the derivative of 5y squared, which we can use the power rule here to get 10y. And remember, whenever we differentiate y, we multiply by dy over dx. That's the chain rule. And then equals, the derivative of this 4 is 0, so that just goes away. Equals, and then we have to take the derivative of 2xy. So when we take the derivative of 2xy, right, we can move this to the front, and we're just left with 2 times the derivative of xy. So that'll be 2 times whatever the derivative of xy is. So to take the derivative of xy, we have to use the product rule, because we have a variable multiplied by a function. You have to remember y is a function in itself, so you can't. So we're going to have to use the product rule here. So to do that, we do 1d2, so we leave x how it is, multiplied by the derivative of y, which is dy over dx, right? And then we add 2d1, so we leave y the same as it is now, multiplied by the derivative of x, which is just 1, right? So that's how you differentiate xy. And so now all we have to do is get all of the dy over dx's to one side and then factor it out. And then we can solve it from there. So to do that, we can do negative 10y dy over dx equals negative 2x, right? I'm just bringing this 2x to the other side, plus 2x dy over dx plus 2y, right? Just distributing that 2. And now we can bring this 2x over, 2x dy over dx. Right, to get negative 10 dy dx minus 2x dy dx is equal to negative 2x plus 2y. Right, and since these have a dy over dx in common, we can factor it out. Negative 10, sorry, that should be 10y. So negative 10y, right? And then minus 2x is equal to negative 2x plus 2y. And from here, to solve for dy over dx, we just have to divide by this term here. So we get dy dx is going to be equal to negative 2x plus 2y over negative 10y minus 2x. And if you notice, all these terms have a 2 in common, so we can cancel those out. So that'll just be, that'll be negative x plus y over negative 5y minus 2x, minus 2x. No, sorry. Just minus x. Mine is a little slow today. All right. And if you wanted, because I think your quiz has shown that the derivative equals x minus y over 5y plus x. That's equivalent because you can take a negative out of all of these, like that. And that'll be equivalent to what's on your sheet. All right, and that is our answer. That is how to take the derivative of that. All right, and from here, we have a second part to this question, right? And I'll leave dy over dx is equal to x minus y over 5y plus x. And for the second part of this question, we have to find the value of d squared y over dx squared at point -2, 0. Right, so we're looking for d squared y over dx squared at -2, 0. Right, and this just means take the second derivative. Right, so we have to differentiate this again. So we have d over dx, this, yeah. So we have the second derivative, d squared y over dx squared is equal to the derivative of this. And now for this, we have to use the quotient rule because it's a fraction. So we have low d high, which is going to be 5y plus x, right, times, like, that's our low, and then we have to do d high. So this times the derivative of the top, which is, yeah, that's a y. So the derivative of x is just 1, and the derivative of negative y is going to be negative dy dx, right? So we have low d high minus high d low. So we have x minus y is our high. There you go. Okay. I just wanted to make sure you could see it. So low d high minus high d low. So we have to take the derivative of 5y plus x. And the derivative of 5y plus x is going to be 5y here. Oh, shoot. My bad. The derivative of x is 1. So that is 1 minus dy dx there. My mistake on that. Right, so we have 5y plus x times 1 minus dy dx minus high d low, which is this, and the derivative of 5y, that's going to be 5 dy dx plus 1, because the derivative of x is 1. Whole thing over low squared. So 5y plus x squared. Right, here we can do some algebra. We can plug in dy dx for all of these. Right, so we have d squared y over dx squared is equal to 5y plus x times 1 minus, and dy over dx is going to be equal to this here. So x minus y over 5y plus x. And this is a lot of writing, but in a second it'll get a lot simpler. Minus x minus y times 5, and then dy over dx is this here, x minus y over 5y plus x, plus 1. Whole thing over 5y plus x squared. And now we could do some more simplifying by FOILing this out and then combining like terms and all that. But one thing we can realize is this is at point -2, 0. So already we can just plug in -2 for all the y's in here and 0 for all the x's. And that'll make it a lot simpler to solve this. So we can just do this. So 5y is going to be -10 because y is -2. X goes away because it's 0. So you have -10 times 1 minus, so x is going to be 0 here. Negative y is going to be 2, right? So this is going to be 1 minus 2 over -10. 2 over -10. Since we have this 5y here. All right, minus x minus y is going to be 2, right? X is 0, y is... What am I doing? I messed up all of these. Okay, let me back up. I'm sorry, my mind is slow today. So, x is negative 2, not y. So anytime we have a y, that'll go away since y is 0. So here, this y is 0, so this term goes away. And we have plus x, so that'll be negative 2 times 1 minus, this is negative 2 minus 0 over 0 plus negative 2. So these y's will go away and we just have x over x. So that'll be 1 minus 1. Right, and we can see that this term will go away since that'll be 0. So we have minus x minus y is going to be negative 2, right, times 5 times, we already saw this fraction over here, and that's equal to 1 plus 1. And see, this is already much simpler than looking up here and trying to do some algebra. The whole thing over, 5y plus x, that's going to be negative 2. Once we plug in negative 2 and 0 squared. So this is going to be negative 2 times 0, so this whole term is going to go away. And then we have negative times negative 2, so this is going to be 2 times 5 times 1 is 5 plus 1. So here we have 2 times 6 is 12. Right, so we have 12 over negative 2 squared is 4. And so that is equal to 3. So what this 3 means is the second derivative of this function, not function, of this equation at negative 2, 0 is 3. And that's how you do 1b. All right. And so for the next one, kind of the same as the first part of this question. We had to find dy over dx given cosine xy equals x cosine y, right? And so we have to take the derivative, right? And so to take the derivative of cosine xy, remember, whenever we have cosine of any function of x, we take the derivative. That is going to be negative sine of that function times f prime of x, right? So what we do is we leave the inside, change this to negative sine, because negative sine is the derivative of cosine, and so we leave this the same, so take negative sine of whatever was inside, multiply it by the derivative of the inside. That's the chain rule. Right? So let's take the derivative of cosine xy. We can see we have negative sine xy, right? Because we leave this the same and do negative sine, and multiply by the derivative of xy. And we saw this in the last equation when we're differentiating xy, we have to use the product rule. So doing this, we get x times dy over dx, right? 1d2 plus y, which is 2 d1, which is that, because the derivative of x is 1, right? So now we have equals the derivative of x cosine y. And this one is purely product rule. There's no, well, there is going to be a chain rule. But, so to do the product rule for this one, we have x, we leave it the same, times the derivative of cosine y. And like we did here, we change cosine to negative sine times negative sine y, and then multiply by the derivative of the inside, which is dy over dx, right? And that's the first part of the product rule. That's our 1d2. And so now we have plus, I'm going to write it down here because I'm out of space, but we have plus cosine y times the derivative of x, which is just 1. So this is our equation for this one. And to do this, to find dy dx, we have to bring this to this side, like we did last time, and factor out the dy over dx. So we have x dy dx plus y. I'm going to do this all like in one step. That's going to be, yeah, never mind. I'm going to leave negative sine xy in there. So we have negative sine xy times x dy dx plus y, and then plus sine y dy dx, right? Because or x sine y, because I'm adding this x negative x sine y dy dx to both sides, and that's just going to be equal to cosine y. All right, so from here we can distribute this negative sine xy to get negative x sine xy dy dx minus sine, or minus y sine xy. Right, I'm just distributing this negative sine xy to both of these terms, plus x sine y dy dx equals cosine y. Okay, so from here we can bring this to this side and then factor out the dy over dx, since these will both have it in common. So we can do that all in one step. So we have dy over dx times negative x sine xy, and then this term we'll move it over here, so we only have to worry about this here. So we have plus x sine y, right? We just brought this over here and factored out dy over dx from both of those. So that'll be equal to cosine y minus plus y sine xy. Okay, and here all we have to do now is divide by this here. So we have dy dx equals cosine y plus y sine xy over negative x sine xy plus x sine y. And we are done for that. Alright, yep. And for the next one, this one is kind of similar to 1b, except we don't have to take the second derivative of anything, which is always annoying. Alright, so for this one we have 4x squared plus xy equals 10 dy over dx equals negative 7/2 at some point xy. And for this we have to find that x and y value. That'll make the derivative equal to negative 7/2. So to do that, first we have to find the equation for dy over dx. So we have x squared plus xy equals 10. And to get dy over dx, we have to take the derivative. Right, and the derivative of x squared is going to be 2x. Derivative of xy, again we see this, that'll be x dy dx plus y by the product rule, and that's going to be equal to 0. since the derivative of any constant is 0. And this one's really simple for getting dy over dx alone. So we have x dy dx is equal to negative 2x minus y. Why did I do that? Minus y. Yeah, and that's it for now. And to get dy over dx alone, we can just divide by x. And I'll just do that now. That, right? And so this is our equation for dy over dx. And this this question actually has infinite solutions depending on what you choose for y or x. But the easiest way to do this is you see dy over dx equals negative 7/2. And these are both fractions, right? So if we make x equal to 2, that'll make y super simple to solve for. So if we say negative 7/2 equals negative 2 times 2 minus y over 2. And we can say x equals 2 down here. Right, since that would make this denominator equal to 2. And so here, it's easy to see that we have negative 7 equals negative 4 minus y. And here we can just solve for y and say y equals 3. Right? So the point that we're looking at is 2, 3. And that is our answer for that one. And again, you could choose any value for x, but 2 and 3 are going to be the simplest ways to go about that problem. Right? And for the next one, we have for 2x over 3y equals sine y. Calculate dy over dx. Okay, so we'll start this as normal. 2x over 3y equals sine y. And because this is a fraction, we can already see we're going to be using the quotient rule. Right, so we have d over dx. And so we have low d high. So our low is 3y times the derivative of 2x, which is 2, minus high d low, minus 2x times the derivative of the bottom, which is 3, times dy dx, right? As derivative of y is dy dx. And that'll be equal to the derivative of sine y. So the derivative of sine is cosine. So we have cosine of y. Remember, we leave the input the same, then multiply by the derivative of the input, which is dy over dx. From here, we just have to get dy dx alone. So we have negative cosine y dy dx minus 6x dy dx, and that's just this part here. And that's equal to negative 6y. That's here. I brought this to the other side since that has no dy dx. And here we can factor out dy over dx, right, to get negative 6y. Hold on a second. Oh my gosh. I'm sorry. I did not do the quotient rule correct at all. Okay, my bad. So this is our low d high minus high d low. I completely forgot about low squared. So that'll be over 3y squared. Yeah, don't forget to do that. So from here, the quickest thing to do would be to multiply by 9y squared to both sides to get rid of this fraction. So we have 6y minus 6x dy dx is equal to 9y squared, because that's this here, times cosine y dy dx. Okay. And from here, we can do what we were doing before. We got negative 9y squared cosine y dy over dx minus 6x 2y over dx is equal to negative 6y. Okay, so we have dy over dx times negative 9y squared cosine y minus 6x is equal to negative 6y. And here we just divide by this to get dy over dx equals 6y. I'm pulling out a negative. You could also pull out a 3 if you wanted, but we're not going to do that. We can just leave it here. So we have 6y over 9y squared cosine y plus 6x. Right. And yeah, if you wanted, you could pull out a 3 to get 2y over 3y squared cosine y plus 3x. But we're not going to do that for this one because it doesn't matter. And so that's how you do this one. And for the bonus, this is the last one. You give us a bonus question, which is for f of x equals f of y. Calculate d squared y over dx squared. So we just have to calculate the second derivative of this. So we start with f of x equals f of y. Take the derivative. Right? So the derivative of a function of x, that's going to be f prime of x. Right? And this is going to be the derivative of f of y. So if you remember, if we have g of f of x, the derivative of that, so we have a function inside of another function, right? So we're taking the derivative of a function of x. So this is just the definition of the chain rule here. We leave the input as the same, multiply by the derivative of the input, right? So we have the derivative of the outside function with respect to the normal inside function times the derivative of the inside function. So plugging this into here, we have the derivative of the outside function is f prime. So we have f prime, leave the inside as it is, f prime of y, times the derivative of the inside, which is dy over dx. And if you're wondering why we do that here, why we don't do that here, is, well, we actually do, because we have the derivative of the outside, which is f prime, and we leave the inside the same, which is stays at x, and then multiply by the derivative of x, which is just 1. Alright, so that's why we don't put a like dx over dx here, because that's just 1. And it's easy to see that dy over dx is equal to f prime of x over f prime of y. But we are not done, because we have to take the derivative again. So we're trying to find the second derivative. So we have d squared x over, d squared y over dx squared is equal to the derivative of this. And to take the derivative of that, we have to use the quotient rule. Okay, so we have our low d high, so f prime of y, so that's our low d high, so times f double prime of x minus high d low is f prime of x times the derivative of f prime of y. So to take the derivative of f prime of y, you have to do the same thing you did to take the derivative of f of y. So we leave this how it is, so we have f double prime of y, right? We leave this the same and multiply by the derivative of the inside, which is dy over dx. Whole thing over low squared, which is f prime of y squared. Okay, and we can plug in this for here to get f prime of y, f double prime of x, minus f prime of x, f double prime of y, and this is times f prime of x, and I'm putting this whole thing over f prime of y. So that was just these multiplied by this, and this whole thing is over f prime of y squared. And so to get a common denominator for up here, we can multiply this whole term here by f prime of y over f prime of y. So if we add an f prime of y to the front and divide by an f prime of y, that would give us a common denominator of these. And we could write this whole top as one fraction over f prime of y squared, and then we could bring this f prime of y squared to the top. What I mean by that is, once we combine these two smaller fractions, we would have some a over b, right? Whole thing over c. And if we think about it, this c is really a fraction where it's c over 1. And if you remember, whenever we divide by a fraction, we actually multiply by the reciprocal. So we would have a over b times 1 over c. And this would go away. And that would give us a over bc. So that is how, if we combined all this, we can multiply this f prime of y squared by this f prime of y to get f prime of y squared by multiplying these two f prime of y's together times f double prime of x minus f prime of x squared by multiplying these two f prime of x's times f double prime of y. And this whole thing is that fraction thing I was showing you, where we get f prime of y cubed, because we have this f prime of y squared times this f prime of y. We're left with this here. And yeah, that's how you do the second derivative of that one. Whenever you do second derivatives with implicit differentiation, it's always a lot of work and takes a good amount of time. D squared y over dx squared. And yeah, it'll always give you some fraction here where you can make a common denominator and multiply this to the bottom. And yeah, so that is, I think he gave you this as a practice worksheet, but if not, those are just some practice problems you can try on your own.